billahi minash shaitanir rajim. Bismillahirrahmanirrahim.
Assalamu alaikum warahmatullahi wabarakatuh. May peace, mercy and blessings of Allah Ta'ala be upon all of you, and also may Allah Ta'ala shower His peace, mercy and blessings on our Prophet Muhammad Sallallahu Alaihi Wasallam. Today's video is going to be very interesting because it's going to be about the Quran and the theory of relativity. One of my friends once said that if the theory of relativity could be found in the Quran, then there would be no confusion or no argument that the Quran is from a divine origin. So now let's look at my computer and see whether we can find anything about that about the theory of relativity in the Quran.
Okay, now let us look at in which which surah or chapter of the Quran this unique ayah or verse is coming in, and how is this connected to the theory of relativity. First, let us listen to the ayah number 75, verse number 75 of chapter number 56 and verse number 76. Let us listen to it now.
فلا أقسم بمواقع النجوم وإنه لقسم لو تعلمون عظيم.
Okay, now we heard, and what does that mean in English? Then I swear by the setting of the stars. That's chapter, verse number 75 and 76. And indeed, it is an oath if you could know most great. Now, the translation of the Quran, there are multiple translations. Although there is only one Quran, there are multiple translations. And these translations sometimes tend to differ. So let us look at some of the popular translations for this verse number 75. The first one is I call to witness coming down in parts of this Quran which is different to the other translations. This one says, nay, I swear by the places of the stars. Furthermore, I call to witness the setting of the stars. So I do swear by the positions of the stars. I swear by the positioning of the stars. Nay, I swear by the setting of the star. Nay, I swear by the falling of stars. I swear by the orbit of stars. I swear by the stars' positions. I swear by the setting of the stars. So, as you see, majority of these translations point to the setting of the stars and their locations. And now let us look at what the theory of relativity, how it was proved by Albert Einstein. There was a solar eclipse at that time in 1919. This is a photo of that solar eclipse. This early photograph shows the total solar eclipse on May 29, 1919. And this is an explanation of why the location of the star changes. This is the actual location of the star. This is the apparent location of the star, and the path of the starlight. It first from the actual location when it comes towards the sun's gravitational pull alters the path of the starlight, and then for someone who is on Earth, it looks as if the apparent location of the star is here. We are above, but actually the actual location is below it. Einstein's general theory of relativity suggests that the sun's gravity bends the path of light from the distant stars. It's a testable prediction only during a total solar eclipse. The eclipse of 1919 fit the bill nicely. And this is you can read more of it. I will leave the link to this in the description. You can see the link to this page so that you can go into it and look at it in detail. It was this guy, Sir Arthur Eddington, who was astronomer who headed this mission to Africa to check whether the general theory of relativity is true or false. And this is a young Albert Einstein. So, in conclusion, what can we say? The bottom line: the solar eclipse of May 29, 1919 was the day astronomer Sir Arthur Eddington verified Einstein's general theory of relativity by observing how stars near the sun were displaced from their normal positions. This apparent change in position happens because, according to Einstein's theory, the path of light is bent by gravity when it travels close to the massive object like our sun. Okay, thank you. I would also like to hear your opinion on this. Okay.